Okay, you guys, this is number 8. This is a Gibbs free energy problem. So we're going to calculate the Gibbs free energy of the oxidation of elemental sulfur to sulfur dioxide. So in order to do this, you're going to need the enthalpy and the entropy values from your gold sheet. So first, let's calculate the delta H value. We did this in number 6, so we're going to do products minus reactants. Remember, with the enthalpy value, a element itself has an enthalpy of 0. So it's going to be the sulfur dioxide gas, the negative 269.9 minus 0. So our value is negative 269.9 for kilojoules. Remember, a negative enthalpy in exothermic reaction is the favorable thing. So keep that in mind. Next, we're going to calculate the delta S value, just like number 7, products minus reactants. For this, entropy, everything has an entropy value. So we're going to take our products minus our 2 reactants, and our value is 11.62 joules. So that is going to be an increase in entropy, a really small increase in entropy, but it's an increase, which again is favorable. So my assumption is if I have a favorable change in enthalpy and a favorable change in entropy, this is going to be a spontaneous reaction. So we'll check that at the end. So now I'm going to use my Gibbs free energy equation. My delta G is equal to delta H minus T delta S. So I'm going to plug in my values that I just calculated. Remember, my enthalpy was in kilojoules, so I'll keep that value. I was given my temperature in Celsius, so I needed to add 273 to get that to Kelvin. And then the entropy value was in joules. So I converted that to kilojoules by dividing by 1,000. So I moved my decimal over 3 places. So notice at room temperature, that entropy, small entropy value isn't going to make a huge difference. So I got a Gibbs free energy of negative 273.4 kilojoules. A negative delta G value tells us that this is, in fact, a spontaneous reaction.